Good afternoon, everyone. Welcome to the STEM Digital School. This is grade 5, Natural Sciences and Technology. So, guys, just as you know, we are going to continue from where we left off yesterday. All right. Remember, guys, please do not switch on your videos. All right. So, throughout the session, do not switch on your videos or webcams. You can raise your hand if you have a question or an answer about something, or you can use the group chat. And also, let's keep chats to a minimum, right? And only about what we are dealing with in class. Okay. Hello, everyone. I see you. I see you there in the group chat. All right, cool. Let's get into it. Stored energy in fuels. All right, just as we did yesterday, I want to hear from you guys what you learned from yesterday's lesson or what you have learned so far. Okay, so you can raise your hand to share with me, or you can type it in the group chat. What did you guys learn yesterday? Or what have you learned so far after you guys revised your work? Okay, the name is user. All right, cool. Let me just unmute you there. Okay, hello.
Hello, ma'am.
What's your name?
Nzako.
Nzako. Okay, cool.
Yes, ma'am.
Nzako, share with us what you learned yesterday.
I am new, ma'am. I just came in today.
Oh, you are new. All right. So Nzako, we are doing energy and change, né? So you can just follow in your textbook and then just follow as well in the class. So if you need any additions or you want to write down something, you can gladly do so. All right. Welcome,
Yes, ma'am.
Nzako. Awesome.
Yes, ma'am.
Okay. So guys, what did you learn yesterday? What did you learn from class yesterday? Guys, I'm waiting for answers. What did you guys learn yesterday? Okay, Sakura.
Must I talk about what we learned out of the revision or was the revision in advance?
When I'm talking about revision, I just mean this week. Remember, I told you guys yesterday that you guys should go read through what we have been doing throughout the week, because some of you guys did not basically be able to answer my questions yesterday. So you can just talk about yesterday or the whole week. It's up to you.
So we were learning about energy
Mhm.
and fuel and what
Right.
and what energy is in what type of object. Like candles have wax in it and wick. So whenever you burn the wick, then you'll get heat and light energy. Also, if you burn wood in a fireplace, you can also get the same thing.
Okay, wonderful. Thank you very much for sharing, Sakura. All right. I see Karine says we learned about stored energies in different types of fuels. All right. So remember we covered coal, we covered wood, we covered candle wax. So those are just one of the different types of fuels. Okay. Karine.
Hello, ma'am.
Okay. Hi.
Hi, ma'am.
How are you?
Fine, thanks, and you, ma'am.
I'm
It's
well,
still
thanks.
Karina. I was in a rush, so I put a Y by my name.
Oh,
Sorry
okay,
for the
no
confusion.
problem. Okay.
Thank you, ma'am.
All right. You're not giving me an answer. What did you learn yesterday?
I wrote it in the chat, ma'am.
You can say it again.
Okay. We learned about stored energies in different types of fuels,
Okay, so give me examples of the different types of fuels.
like let's say candles.
Candles. All right.
Yeah.
Okay, thank you very much, Karina.
Thank you.
Hey, Bulelwa, I see your hand is up. Okay, Bulelwa.
And I was going to say the same thing as her,
Okay.
but I wanted to give a different example.
Give me another type. or fuel that we learned about?
Ma'am, there is coal.
Uh-huh.
We
And where
learned
is
about
coal
canopy.
used? Where is coal used?
Ma'am, it's used to make like when you're brine, ma'am, you use coal.
Okay, and yesterday we learned something new about coal. What does coal make, or rather, how do we as a nation use coal?
Um, hmm,
Are you winning there? Okay. Just as you're thinking about it, you can put it in the group next. All right. So
yes.
I hope everyone has learned something or had learned something from yesterday's lesson. Okay, cool. I think I have some revision pictures here. Yes, so some fuels are energy sources for engines and power stations. This was mainly what we learned yesterday, right? About the petrol, how it helps makes, or rather how it helps cars to move. Okay, and we said that this petrol comes from fossil fuels. Okay, so the plants and animals that died long, long ago, and then they decomposed to form these fossil fuels, and then they form the petrol or the diesel, and the petrol gives energy for the movement of the car. All right. Cool. And then we spoke about coal. So Bulela, just pay attention. Here is the function of coal, the other function of coal. So coal is not only burned in our homes for cooking and keeping us warm, but it is also burned in large quantities to make electricity. Right? We said that we have an example there of a power station, which is a large factory where coal is burned in large amounts to provide electricity. Okay, a very important function of coal there. Okay, so in order to light the fuel, you had to put a small amount of energy. So this is when we were covering the wood, right? We said that if we burn wood, we can get fire, and we can, or rather we can get light, and we can get heat as well. So this is where this is stemming from, right? So the difference between energy you put in and the energy fuel that you give out, or rather how much energy was stored in the fuel. Okay, so let me just repeat that. The difference between the energy you put in and the energy the fuel gave out is how much energy was stored in the fuel. All right, so guys, just if you want to add on into your books, just do so now. All right. Then the next point says the output energy obtained from a fuel is greater than the input energy needed to make the fuel burn. All right. So as we just entering into this slide, we are going to get into a new subtopic, which is burning fuel. Okay. But we will get back to this slide. Let me just continue on to this next one, which says burning fuel. All right. So guys, if you are following in your books or you are writing things down, just write this heading, which is burning fuels. Okay, Malik, see your hand?
Ma'am,
Yebo.
I just want to can you when can we go online?
Excuse me, can you just repeat that for me?
When can we go online?
To write the test.
Yes, ma'am.
Okay, after your lessons, after school.
Oh, thanks, ma'am.
Okay, cool. All right, guys, so we're on a new topic, which is burning fuel. All right. So each fuel has chemical energy, all right? And this starting energy is in the fuel is called input energy. So just like what was explained in the previous slide, okay? So when fuels burn, it gives out heat and light energy. The example I gave was wood as well as the coal, okay? Then the energy that it changes into is called output energy. Remember, we had already established that wood has energy in that is stored in it. Okay, so the moment we burn it, right, then it releases light as well as heat, and that light and heat is called output energy. All right. So here is just a mini indication or process of the burning process, where we have input energy, then we have the burn process, and then we have the output energy. Okay, so I'm just going to give you guys a few minutes for, not a few minutes, a few seconds maybe. I don't think you guys need a lot of minutes to write down this slide. Okay, Faith?
Hello, ma'am.
Hi, how are you?
Ma'am, I just wanted to tell you that I'm sorry that I was late.
Oh, okay, no, it's fine, Faith, as long as you're in class, ne?
Okay, ma'am.
Sure. Guys, remember I said keep chats to a minimum. Otherwise, the chats are going to be closed for you guys. Okay, so guys, can we move on? Just indicate for me using that yes or no button. Okay, I see a no. Okay, and it's from Malik. Malik, once you're done, just indicate for me. Ne? Okay, we have. Okay, Malik and Sako, just indicate for me when you guys are done. All right, so we can move on. So remember, guys, each fuel already has a chemical energy which is stored in it. Okay, and this starting energy is what we call the input energy. Okay, and once we burn the fuel, it gives out heat and light energy, and this heat and light is what we refer to as output energy. Right, so this heat as well as the light, this is what we call the output energy. Okay. So most fuel always require us to burn them, right, in order to get out this energy, right? So in order to release a particular energy from a fuel, we need to burn it. Okay. So that's in short what this section will be talking about. All right, so I still see we have one more which is still standing. Okay, so Malik, are you done? Can we move on? All right, beautiful. Okay. So burning fuel provides us with the energy that we can use. Okay, very important. Burning fuels provides us with the energy that we can use. So remember that energy is stored in the fuel, and once we burn those fuels, then we can utilize the energy which was stored in those fuels. For example, wood has energy. Once we burn wood, then we can use that energy which was stored as a source of light or a source of heat. Okay. Right. So question, what does a fuel need to be able to burn? What does a fuel need to be able to burn? What does a fuel need to be able to burn? Okay, Bulelwa.
Ma'am, I think it needs heat.
You think it needs heat?
Ma'am?
Okay, Bulelwa, your line is quite
No.
your line is quite okay. It's not really glitching. There's a lot of echoing that's happening in the background. but Bulala said you think it needs heat. Okay, but you can also just type it in the group chat and then I'll read it out to the class. Okay. All right, so let me see from the chats. I see you guys said light, fuel needs fire for it to burn. Okay, Koto says energy, Tafika says, oh, okay. Then Sakura says fire, Gudran also says heat, and Karina says fuel needs fire. Okay, so Sakura, I see you have already answered in the group chat. Let's see what Shengi has to say. What does fuel need to be able to burn?
I think it is fire.
It needs fire.
Yeah.
Okay, thank you very much. All right, so Shengi says it needs fire. Leanda, what do you think?
Ma'am, I think it needs heat.
You think it needs heat? Okay. All right, thank you very much, Leanda. Okay, Lumbala, what do you think?
I think it needs heat.
It needs heat. Okay, thank you very much. Okay, guys. So I see most of you saying fire and others are saying to burn it. It needs heat. Okay, cool. So let me ask this question. If we have wood, yeah, and then I'm using a match, right? So I create a spark of fire, right? And I light up the wood, okay? So the wood is obviously going to do what? It's going to give me that fire. It's going to show those flames of fire, okay? So my question is on, before that fire can start, what is required? So before we can see that fire with our eyes, what do we require? And that is what the question means when it says, what does a fuel need to be able to burn? Okay, so Faith, okay, I like that, Faith. Faith says you need fuel, all right? That is actually on the right track. You do need the fuel. Koto says energy, all right? Yeah, I see. Leander says coal, all right? So remember, coal is a type of fuel, all right? So I could be using coal, I could be using wood, right? So, okay. All right, so okay. Let's see what the answer is. So Kozo repeatedly wrote that in the group, saying that energy is required to make fuel burn. All right, and I can't remember who else wrote that, but yes, Kozo mentioned that we need energy for fuel to burn. Okay, so that is what we call the input energy. Another thing that fuel needs in order to burn is oxygen. All right, so there are three requirements for fuel to burn, and that is our input energy, and then we also need the oxygen. All right, and this oxygen, we get it from the air around us, or rather the fuel gets the oxygen from the air around us. Okay, so there are other gases present in air as well, but they do not burn. Okay, so when something burns, we say that it is combusting. So that's a new word, right? So a new word for burning that we will be using as we go along with this lesson is combustion. Right, I see hands. Leander?
Oh, sorry, ma'am. I forgot to put down my hand.
Oh, okay, no problem.
Thank you, ma'am.
Okay, so guys, I'm just going to give you a few seconds for this, or rather a few minutes, and then we can continue. Okay.
Hello?
Hi, Tafika.
Ma'am, I wanted to
Mhm.
ask, is is this going to be included in our test?
No, remember the test is just on term 1 as well as term 2. So it's life and living as well as math and materials.
Oh, thank you, ma'am.
All right. All right, I see a hand.
Hi, ma'am.
Hello, what's your name?
Ma'am,
What's your
ma'am, my
name?
name is Tandy, ma'am.
Tandy.
Yes, ma'am. Short to
Why
Tandy,
didn't you
ma'am.
write your name then?
Ma'am, I forgot, ma'am. Sorry, ma'am.
Okay, yes.
Ma'am, I will. Ma'am, what are we doing, ma'am? I'm new, ma'am.
Oh, you knew. Okay, so we are looking at energy and change. That's a topic on term 3. I think you can just turn there in your book, your textbook, and then it is stored energy.
Welcome, ma'am. Thank you,
Stored
ma'am.
energy in fuels. All right, cool. All right, guys, can we move on? Can we move on? Just indicate for me yes, no, no, yes. Okay, I see it go slower. All right. Okay, guys, can you guys just when you log in, please use your real names. Okay, when you guys log in, please use your real names. It just makes it easier. Okay. Karina? Karina, your hand is up. What's up? Okay. Right, guys, we are moving on. Cool. So here, guys, we have an experiment, right, that we could have done had we been in class. Okay, but you guys can also do it when you guys are at home, but of course with the supervision of an elder. All right, so don't do it alone. You need to do it with an elder. So this experiment is just basically showing us that we require input energy as well as oxygen in order for a fuel to burn up. Okay, so here we have our candle, right? And we have lit up the candle and it has caused a fire. So the moment we put up a glass jar over the candle, then what's going to happen is that the candle will burn up for just a short period of time, all right? Probably like 10 or a few seconds longer, then it's going to be off. And the reason for that is because it would have used up all the oxygen that was covered in the jar. All right. So this experiment is just basically showing us that oxygen is required for a fuel to burn. Okay. All right. So let's just move on. So examples of burning fuels. we can say that energy stored in fuels is called chemical energy, right? Here are some examples of the chemical reactions that release energy. The petrol inside a car engine has to burn to release energy for the car to move. Okay, the chemicals on the head of the match allow it to catch fire when you strike it against the matchbox. And then you have a battery and you have a light bulb, but but you have to use wires to connect the battery to the light bulb before the energy can be released to form light as well as heat. Okay, so I'm just going to give you guys a few minutes maybe to write down some of these examples, then we can go on to show the pictures. Or let me just show you guys the pictures first. So here we have the example of the matchstick and the matchbox, and here we have an example of the electric circuit, which is found in a torch. Okay, so what the last example was saying is that the light bulb needs to be connected to the battery. Okay, so I'm going to give you guys a few seconds or minutes rather to write down this slide, and you guys can just also share with me some of the examples that are in your book with regards to burning fuels. Okay. All right, guys, if you are done with writing, you can also share some of the examples that your book has. Okay, I see Faith. Faith. Hi, Faith.
Ma'am,
Mm-hmm.
can you hear me?
Yes, I can hear you.
Ma'am, I just have a little two paragraphs and examples. Can I read them to you?
Yes, you can read them to us.
Fuels need heat to set them alight. For fuels to keep burning, heat and oxygen are also required.
Heat
Oxygen is
and
a gas.
oxygen. Okay.
Oxygen is a gas in the air. All fires.
Okay, Faith.
Ma'am?
Faith. Just try reading a bit louder so that everyone can hear you clearly.
Okay, ma'am.
All right.
Oxygen is a gas in the air. All fires need oxygen to keep burning. Fuel, heat, and oxygen for the fire triangle. If any of these are taken away, the fire will be extinguished. This means it will stop burning. To light a candle, a burning match is brought near the candle wick. The heat for the flame melts the wax and turns a small amount of candle wax fuel into a gas. This gas mixes with the oxygen in the air to make a flame. A candle will only burn if it has fuel, something that burns. Oxygen found in the air around us. Input energy, something to start the burning.
All right, beautiful. Thank you very much, Faith.
Thank you, ma'am.
Awesome. Okay, so let's hear Malik.
Ma'am,
Yabo.
can I also read, ma'am?
Yes, are you reading examples of burning fuels?
On my book, ma'am.
Yes, and I'm saying, are you reading the passage of burning fuels?
Ma'am, can I raise my what page is it on, ma'am?
I don't know what book you're using, but what's the
I'm
heading of
using
what you wanted
Platinum,
to read?
ma'am.
Okay, I'm not using the Platinum textbook, but what is the heading of what you wanted to read for us?
I wanted to read, ma'am. I read myself a grade when I get my textbook, ma'am.
Okay, cool, no problem. So
Ma'am,
Sakura says it's page 113.
Okay, thank you.
All right. Okay, Sakura.
Ma'am, it says here in my book, ma'am. We, can I read it? Ma'am, it's like a paragraph, ma'am.
Okay, cool. Go for it.
We use fuels as sources of useful energy. Coal, natural gases, and paraffin are also fuels. They are useful resources of energy that we use every day. We use the stored energy in the fuels for many different things. For example, coal, gas, and paraffin can be used for heating and lighting our homes as for cooking. Candle wax is also a fuel. Candles were originally made by beeswax or various plant wax, but now we are more commonly made of paraffin wax. The energy is stored in the wax, which is used up of the candle burns. The energy is used to make light and some heat. Petrol is a liquid fuel. Energy is stored in the petrol. Cars and taxis get their energy from petrol. The petrol is stored in the car's petrol tank. When the petrol is burned energy, in the car's energy, the heat energy makes the engine work, which makes the car move.
All right. Beautiful. Thank you very much for sharing, Sakura. Okay. Okay, guys, are we done? Are we done? Can we move on? Then I'll take one more hand. Can we move on? I believe everyone is now done writing down. Ooh, okay, maybe it says they're not done. Okay, let me take a hand. Lesedi?
Burning fuels. What do fuels need to set them alight? The sun or a wood or charcoal fire? A candle and a gas fire are all sources of heat energy. When a fuel burns, heat is created, causing potential energy in the fuel to be changed to heat energy. Fire needs three things to start and to burn: fuel, oxygen, and a source of input energy. What do fuels need to keep them burning? Burning is called combustion. When you light a candle, the fuel that makes the candle burn is the wax. A lit candle will give you out light, energy, and also heat energy. When something burns, a chemical reaction takes place, so the fuel changes into something new. Where does oxygen come from? The air around us is made out of 21% oxygen. When you remove oxygen from a fire, the fire will go out. Yes, ma'am. That's what's written in my textbook.
All right. Thank you very much, Lesedi.
Yes, ma'am. Thank you.
Awesome. All right, so I believe we are all done with writing down some of the examples that I have on screen. So we are just going to move on. I see a lot of hands. I think you guys just wanted to share what your textbooks say. All right, but no problem, guys. I will give you an opportunity if we are done on time. Okay, so these are the examples that we spoke about, right? And we said we need three things in order for fuels to burn. We need the actual fuel with the input energy, right? We need heat and we need oxygen. Okay. So this is the combustion triangle. Combustion triangle, remember another word for burning, or when fuel burns, we say that it is combusting. Okay. Yeah, I see someone here pressed no. I'm not quite sure. Koto, what's going on? You need me to go back? Koto, talk to me. What's going on? And Rafen said, you guys need me to go back. Did you miss something? Okay, so I'm not getting any response from you guys. All right, cool. Let's continue then. Okay, so safety with fire. Safety with fire, that is our next subtopic that we will be looking at. All right, safety with fire. Guys, remember no spamming, otherwise chats are going to be blocked again. Right, so fire is a major source of heat energy for many people, whether it is for keeping warm, cooking food, or for some other purposes that people use the fire for. And then fire is very useful, but it is also very dangerous. That's why we always need to be careful when working with fires, or we need to even stay away from fires. Okay, so great care is needed when using fire, and that's why you guys, as young children, you need supervision of an adult when you are going to do experiments that are using fire, or even when you are cooking. All right, so here we have examples rather than this first picture here, we have an example of a wildfire which has gotten out of control. And then on the next picture here, that is a warning in nature reserves during dry summer months when fires can easily start up. Okay, so guys, we all need to be very careful when working with fire or when we are around fire. Okay, sorry about that. So I'll give you guys a few minutes for this slide, then we can continue. Okay, let me see, we still have hands which are up. Okay, Karina. Okay, Karina, I cannot hear you, and I'm not sure if you can hear me, but I have unmuted your mic and I'm not getting any sound from you. All right, so let's see what Leanda has to say.
Ma'am, I just wanted to read something.
Okay.
With regards to the safety with fire and the burning fuels.
Okay, so you're going to read with regards to safety of fire. Okay, read the one with burning fuels. For safety of fire, we still yet to cover it.
Yes, ma'am.
Okay.
The energy from the sun stored by plants becomes available again when the fuel is burned. A match or lighter heat energy is required to set the fuel alight or to get the fuel burning. Oxygen is the air in the air is also required to set the fuel alight and keep it burning. The fuel, the heat energy, input energy, and oxygen cause burning. The diagram, oh no.
Okay, thank you very much, Leanda.
You're welcome, ma'am.
Awesome. All right. Okay, so guys, are we done? Can we move on to the next slide? Koto, just indicate for me when you're done, all right? As well as Rofense. Just indicate for me when you guys are done. So that I know if we should move on or not. Okay, Leanda says they're done, all right? Okay, let's say, dear, I see you. I see you, Faith. Kenzako, I also see you. Lumbala. Rafens, are you done? Can we move on? All right. Okay, cool. Awesome. So like I said, here we have just examples. This is a wildfire that has gotten out of control. And here we just have a warning sign, right, in a nature reserve. This is during dry summer months because fires can easily start up then. Okay. So dangerous fires can start when the following things happen. All right. So there's dangerous fires can start when we throw away or drop burning cigarettes or matches, knocking over stoves or candles, right? So stoves which use paraffin, etc., or that have open fires, they can cause dangerous fires to start at homes, and candles can also start dangerous fires in homes or houses. Okay, so that's why it's very much important to not sleep with a candle on. So if you are using a candle at home, make sure you switch off the candle or you blow it out before you go to bed. All right, then making open fires in windy weather can also cause dangerous fires, just like in this picture here, right? This picture here. So the fire spreads much more easily when we have open fires and if it is windy. Okay, and that is why also in this picture on the right, they have a warning, right, in during dry summer months, because open fires can start wild, dangerous fires. Okay. So other things that cause dangerous fires is when we leave any open flame unattended. Okay, so an open flame can cause dangerous fire. So when we talk about unattendance, this is when no one is watching the fire. Okay. Then when we leave small children alone in a room where a fire or a candle is burning, this might also cause dangerous fires. Okay, so I'm just going to give you guys a few minutes. Okay, so it looks like time is almost up and we will, okay. So guys, we'll just end the lesson on this slide. Then tomorrow we will continue. Okay, so we'll continue tomorrow, but you guys do have a few minutes to just, a minute or two actually, to just write down what you see on screen. And if you are done, just indicate for me so that I can move on into closing the lesson officially. Okay, Silumbana says they're done. Rianda says they're done. Okay, I see you, Kota. Okay, all right. Okay, Nsako. All right. Okay, cool. Okay, so we'll just look at that tomorrow, just before we look at the other things, or rather before we look at tomorrow's topics. Okay, so guys, these are the textbooks that I am using. I saw some of you guys said that you do not have textbooks. You can get the Via Africa Natural Sciences and Technology textbook on Snaplify. Okay, remember I put up the website name yesterday up in class, right? So you can get this textbook here on Snaplify, it's free, or you can get this Siavula textbook as well on the Thunderbolt Kids website. So it's www.thunderboltkids.co.za. So if you do not have a textbook, you can get either of these, or you can get both of them, right? And if you guys do have any further questions, you can send an email to the school at stemdigitalschool@africateamgeeks.co.za. Guys, enjoy the rest of your day and all the best with your assignment today. Goodbye, guys.